Welcome to the Explainer. Today, we're diving into a really fascinating high-stakes intersection. We're looking at where physical airspace defense actually collides with the digital frontier of decentralized finance. It's this incredible story about how we measure reality, and crazy enough, how the physical microchips inside our computers might literally be lying to us just to save a little time. So you might be wondering, what on earth does tracking a high-speed stealth jet have in common with swapping, say, 10,000 different stablecoins on a decentralized exchange? Well, it sounds like a riddle, but the answer is a shared, profound mathematical bottleneck that's hidden deep inside the processors of our computers. As you'll see, both of these systems are actually fighting against the exact same fundamental geometry problem. All right, here's our roadmap for today. First, spheres versus grids. Second, radar's conversion bias. Third, the DeFi polar pivot. Fourth, FPU Gambler versus ALU Surveyor. And finally, restoring absolute truth. Let's get right into it. Kicking things off with Section 1, spheres versus grids. To really understand this, we have to start by establishing how we actually measure reality. Picture a physical radar system scanning the sky. When it's observing a target like an airplane, the radar naturally uses spherical coordinates. It's measuring range, bearing, and elevation, operating entirely in angles and radii. It completely ignores that flat, two-dimensional X and Y grid we all had to learn in high school geometry. The physical world is essentially spherical, and the radar captures reality exactly as it happens in that natural space. Moving right along to Section 2, radar's conversion bias. This is where the pristine math of the physical world crashes headfirst into our computational limits. Because traditional tracking algorithms demand standard Cartesian coordinates, those rigid X and Y axes, we are forced to translate these beautiful spherical signals into a flat grid. But converting those polar measurements completely warps the data. When you force a sphere into a flat grid, you get non-Gaussian tracking errors. It's a mathematical bias that noticeably worsens as the range of the target increases. So the further away that jet is, the worse the distortion gets. You literally lose the true location of the object simply by converting the math. And it gets wilder, because the hardware doing this math only makes things worse. When our computers use floating point math to approximate these heavy geometric conversions, it permanently destroys the exact mathematical provenance of the original data. Researchers literally call it the wood chipper effect. The processor's floating point unit acts like a giant digital blender. Once your exact data goes through it, it's permanently mangled. I mean, you can never unblend a smoothie to get the exact original ingredients back, right? Same principle here. All right, Section 3, the DeFi polar pivot. Let's shift gears from physical airspace over to Web3. Visionary developers are hitting this exact same mathematical wall while trying to scale decentralized finance. To combine 10,000 different stablecoins into a single pool without fragmenting all the liquidity, developers realized they had to completely mirror Radar's math. They had to abandon flat grids. Target tracking in Radar becomes automated market maker asset swapping in DeFi. Range and bearing become liquidity radii and price angles. They're essentially folding financial trades into a massive 3D globe where everything connects seamlessly. And they absolutely have to do this, because legacy automated market makers rely on those rigid X and Y Cartesian curves. When you try to swap multiple assets on a flat grid, it requires heavy on-chain division and square root calculations that become a total nightmare to manage. It causes severe gas spikes, mathematical drift, and leaves the pool completely vulnerable to exploits like dust grinding, where bots just bleed the pool dry through rounding errors during high volatility. The standard grid simply breaks down under the weight of multi-coin complexity. So, the solution? Enter the polar AMM. By fully embracing this polar pivot, complex multi-asset swaps become highly efficient circular rotations. We're talking simple trigonometry instead of massive algebraic headaches. Protocols like Lens or OrbSwap treat the pool as a circular manifold. Using ancient geometrical shortcuts like the Brahmagupta group product, converting one token to another isn't some heavy equation anymore. It's just treated as rotating an angle. It allows for constant time execution, and it is honestly just incredibly elegant. But here is the catch. Section 4, the FPU Gambler versus the ALU Surveyor. Whether we are tracking a jet or rotating a multi-million-dollar stablecoin swap, the physical hardware executing this complex math is deeply conflicted. Deep inside the silicon of your computer, there are two distinct components handling math. On one side, we have the floating point unit, what we call the FPU Gambler. It's wildly fast, sure, but it is probabilistic. It relies on completely secret proprietary seed tables to essentially throw darts and guess the math. On the other side, we have the arithmetic logic unit, the ALU Surveyor. It is strictly deterministic. It's a bit slower, but it offers absolute verifiable truth, where 1 + 1 equals exactly 2. Every single time on every machine on Earth, it absolutely refuses to guess. Now get this. Today, an astounding 80 to 90% of modern AI compute heavily relies on the guessing game of the FPU Gambler. Because it's desperately trying to squeeze continuous numbers into fixed formats to save time, it constantly drops tiny fractions. This introduces microscopic rounding errors known as mantissa inaccuracy. So yeah, it's fast, but it is highly lossy. The crucial takeaway here is that relying on these hidden hardware approximations introduces non-deterministic drift. In AI, this causes hallucinations. But in a multi-coin DeFi ecosystem, this compounding math error can literally cause fatal stack overflows and collapse the entire system. When you move beyond simple token pairs into dozens of assets, you're actively building in massive systemic fragility if your hardware is just throwing darts to guess the math. So, how do we fix this? Section 5. Restoring absolute truth. To protect these decentralized systems from collapse, developers must actively force absolute mathematical truth back onto the silicon. Here's how you build that resilience. Step 1. You design the pristine academic theory of polar coordinates. Step 2. You have to acknowledge that the FPU Gambler absolutely cannot be trusted on-chain because determinism is the law in Web 3. And Step 3. You forcefully translate those continuous geometric curves into strict, fixed-point integer math so it can be processed safely by the exact logic of the ALU Surveyor. And when you build on this exact math, you unlock some wild new superpowers. By operating strictly within this polar geometry, users can mathematically construct synthetic binary prediction markets directly inside the protocol. It acts as an insurance policy against a stablecoin collapsing, a depeg. You literally just locate an unused polar tick outside the normal peg, build a long position there, borrow and short a second position immediately below it, and combine them into a vertical spread. If the coin permanently crashes, your synthetic option pays out and covers your loss. It's brilliant. Ultimately, none of this works if the hardware is just guessing. Relying entirely on the arithmetic logic unit ensures that our digital financial ledgers remain pure, universally verifiable, and completely free of corporate guesswork. The ALU acts as a globally accountable, undeniable universal witness. No hidden seed tables, no wood chipper effect, just irrefutable hardware facts. We spend an immense amount of energy building perfect, trustless cryptographic systems in the cloud. But as we scale our digital futures into higher dimensions, whether we're tracking global airspace or trading millions in digital assets, we really have to look at the physical chips running the show. So I'll leave you with this provocative thought. If our trustless digital systems are built on physical silicon that is fundamentally guessing, can we truly trust the system? Think about that the next time you dive into DeFi, or just look up at the sky. Thanks for joining me on this explainer. Keep learning, and we'll catch you next time.